Okay, Jim, for sake of example, what I've got again is a late model GM vehicle. I got a sudden drop in fuel economy, sluggish performance. So what I went and did is I pulled the codes out of the ECM. What I found was a code 33. Well, I referred to the manual on that vehicle. Code 33 told me I've got a map sensor circuit problem. Where do we go from there?
Well, that really doesn't surprise me because a map sensor can cause a drastic decrease in mileage and some sluggish performance. But I think what we'll have to do is test this. I would suggest a quick 2-minute test to verify that code before we go any further.
Okay.
Now what we're going to need is a vacuum pump to supply the vacuum that the intake manifold would normally supply. We're going to need a voltmeter. And we're going to need some way to make it run. So I brought along a special tester for that. This is our universal tester again with the correct end on it for plugging into map sensors for this type of testing.
Okay.
So I'll get that plugged in, and perhaps you'd like to do the vacuum gauge while I get the voltmeter turned on.
What your map sensor does is it signals the computer as to how much load is on the engine, and therefore the computer adjusts the fuel mixture and the ignition timing to match that load.
Now what we want to do is watch the voltmeter here. As you apply vacuum, the voltage should change. Okay. And I suggest going to about 15 or 16 inches of vacuum and holding when you get there.
Okay, this is similar to our throttle position sensor test. You want to watch to see if the voltage changes evenly, and in our case it does, and I'm at 15 inches of vacuum, and it holds vacuum.
Right. After you're satisfied that the part doesn't leak at all, go ahead and release the vacuum, and the voltage should go back down to somewhere near where it was before.
And it does. Now this happens to be a map sensor off from a GM vehicle, and it's operating fine, so that is not our problem.
That's right. And since it's not our problem, on the vehicle you spoke about, we would have to go to our book that talks about diagnostic trees and trouble codes and find the map sensor diagnostic tree and just follow the step-by-step procedures for that map sensor. And what you'll find is that you either have a bad vacuum hose or an electrical connection, it could be an ECM again, but somewhere in there is where your problem lies.
Okay, so we know replacing the component at that point in time isn't going to fix our problem.
Right, although one day we found this one on a car that was bad, and let's show the folks how we found a bad one.
Okay.
Once again, we attach our lead. This one is from a Chrysler, by the way. And GM and Chrysler map sensors work the same way.
All right, I'll plug the vacuum hose from the hand vacuum pump in there. Now again, these tests can be done on the vehicle or can be done with the item off the vehicle like we're doing here.
Okay, once again the voltmeter is set on the proper voltage range, and you go ahead and apply the vacuum.
Okay, I'm applying vacuum. Nothing's happening. Nothing at all is happening. I'm at 15 inches. Now the vacuum gauge is staying steady, so the actual vacuum diaphragm in here is okay, but we've got an electrical problem with the map sensor.
That's right, Scott. The electronics in this device is not working, and that's why we don't get a voltage response. So this one is bad.
Okay, that would certainly create our problem. Now, what about Ford vehicles? They got something a little different, don't they?
They certainly do. This is the Ford map sensor. And although it's similar to the Chrysler and the GM in many ways, it's shaped a little bit differently. It has a 3-terminal connection and a vacuum port, but unlike the others, this does not change a voltage. This actually creates a frequency, and we have to read that on a frequency meter or even our tachometer. That'll work real well too. Why don't we go out to the car? There's one on the car. We can just test one on the car to show how it's done that way.
All right.
We'll need our
hand vacuum pump.
Right. We'll need our tachometer. And we'll also need our special tool with the correct attachment for the Ford, and I've got that right here. So let's take everything on out to the car.
Okay. Okay, Jim, here's our Ford vehicle. Set the vacuum pump here, and our map sensor sitting right back here up top, isn't it?
Sure is. Very easy to get at on this particular vehicle. Now, to test this, what we're going to have to do is first disconnect the vacuum line so that we can attach the vacuum pump, and the electrical connector so that we can attach the tester. Now, on this particular unit here, there is a little locking tab that you just push down with your thumb, and that aids in pulling off the connector. Now here we have our universal tester, and I'll plug the Ford map sensor lead to it. Now, we don't use the light at all on this. All we're using this is for a power supply and a place where we can take the generated RPM and pick it up with the tachometer.
Okay.
Now let me explain that. First, we'll simply plug into the map sensor, And then the map sensor is actually working now because we have our own power supply.
Sure.
It's producing a frequency based on what the map sensor is putting out right now. And for us to read that, all we have to do is take our meter and turn it to the 4-cylinder tachometer scale.
Okay.
Attach the positive and negative leads, and there we have our frequency.
Sure.
Now to change that, as the engine does, we'll attach our vacuum pump so that you can apply vacuum to cause the reading to change, and that way we'll be able to see if this map sensor responds to vacuum.
Okay, we're at about 491 just for reference point, and I'll start pumping it up. We'll see if it changes. And it is changing nice and slowly as I pump the hand vacuum pump up slowly. So what we're looking at is the electronics in it is working, and also the vacuum diaphragm is working. I'll stop pumping. We'll just make sure that diaphragm holds.
Right, watch the gauge for a few moments and make sure it doesn't leak down.
I can just release the pressure. We should be back about to our original reading, 490, and we are.
Right, so now we know we've got a good map sensor on this vehicle.
Testing your Manifold absolute pressure sensor is easy. Let's look at the procedure involved in testing this sensor. First, connect the universal tester to the Manifold absolute pressure sensor. Connect a vacuum pump to the vacuum port located on the sensor. Connect a digital multimeter to the sensor's electrical connection. Set the meter to the appropriate scale for your vehicle. Next, observe the reading shown on the meter. Apply vacuum to the sensor and note the meter reading. Typically, 5 inches of vacuum equals approximately 1 volt of change on the meter. Release the vacuum and observe the meter reading. It should be equal to the initial reading obtained earlier. If the sensor tests okay, refer to the proper service manual and follow the diagnostic chart for further testing.
Well, Jim, we still got that same GM vehicle, late model, and now I've got a problem with it at idle. At idle, it seems to want to die on me once in a while, and also I've got that same periodic check engine light that's came back. What do you think?
Well, since you have a check engine light, you're going to have to pull the codes.
Which I've done, and when I did pull the codes, I came up with a code 34. When I went to the manual, code 34 told me MAF sensor. MAF stands for mass airflow sensor, and they're located in a readily accessible spot underneath the hood, right in the air cleaner housing. How's our 2-minute test?
Well, we do have a 2-minute test for the mass airflow sensor, and if you'd like to take and hold this and help me show everyone how it's connected up. This is our universal tester. Now, the first thing you'll notice is we don't have the 9-volt battery on here.
Okay.
I have it connected to a transformer which will supply us with 12 volts for our testing purposes. We could have hooked it to a car battery with the car battery jumper, but this was a little bit handier for our purposes today. The point to remember is that mass airflow sensors are not 9-volt devices, they're 12-volt devices, so don't use your 9-volt battery to try to run these things. That won't work.
Okay, how about our connections?
Well, the connections are, there's 3 terminals. The one over here on the left is positive, so that's where I've got the red one connected.
Okay.
The one way over on the right is negative, so that's ground. That's where the black one goes. And the center terminal is where the pulses come out of. So to that terminal, I have connected the clip for the LED and the clip for this meter, which we're going to put on the RPM scale.
Okay, 4-cylinder scale.
Right, the 4-cylinder scale. We need the tachometer to measure this because these produce a frequency. And the frequency can be measured with a tachometer for our purposes, and the 4-cylinder scale is the most accurate scale for this. Now, I'll hold this and call your attention to the lamp. It should be flickering right now.
It is.
Now, that flickering lamp shows us that this is producing a frequency or pulses, and at the same time we should be able to read them on the meter.
Yep, and we can.
Now, to test this, all I have to do is blow through it because this measures airflow. And of course, when I blow through it, I will increase the airflow, which should cause the lamp rate to increase, and you should get a different reading on the meter.
Okay.
So let's do it a couple of times. Let's watch the meter first as I blow through here.
All right. Way up. 165 counts, and now she's going back down to where it was originally.
Okay, let's watch the lamp.
Yep, the lamp speeds up so much that it actually almost looks like a dim lamp. Now it's back to its flickering.
Right, that high speed. In fact, it almost looks like it's on all the time, doesn't it? Because the frequency is so high and the lamp rate is so high. Now, at this point in time, you might think that this is a good part. But one of the things that MAPS airflow sensors have a habit of doing is coming apart inside, especially in the electronics portion of it.
Sure.
So if you'll take an object such as a screwdriver and tap on that, we should be able to see a change in the output if it's loose, if it's defective. Now, you can't do that with the lamp. You must do that with the meter.
Okay.
So observe the meter while I give it a tap.
Ooh, way up. Way down and way
down.
up.
So it's going to be varying all the time. The reason why this was running when we started the segment was to get it good and warm. If you suspect an intermittent problem with your mass airflow sensor, hook up your tools like we've done here and set it on the counter or just leave it on the car for 10 or 15 minutes. Get it good and warm and then make your test, and you'll find a bad one, if it is bad, just as you and I have done now.
Okay, and this could cause our problem with the engine stalling at idle as well as our intermittent check engine light.
That's right.
Now, there's two styles of these, correct?
It sure is. This one is a 3-terminal, and as soon as I get everything disconnected, perhaps we can show that there are actually 3 terminals in here, and that's where we had the tools connected a few moments ago.
Okay.
Now, the one I'm bringing up alongside is a 5-terminal, and you can see we've got a different type of connector on there, so we can get into all 5 terminals.
Okay.
So what we'll do then is connect our universal tester into the lead, and that will power the mass airflow sensor, and then hook up the tachometer to the output, and we should be getting a reading.
We are getting a reading.
And the light should be flickering.
And our light is flickering.
Okay, now, all I have to do is, again, blow through the device, and we'll see if it works. We'll check the gauge first, I guess.
All right. Gauge goes way up.
Okay,
196
great.
counts, back down.
And now how about the light?
Yep, same thing with the light. Now the light is actually going to almost a full steady beam, so that's showing us our frequency change.
Right. And then, of course, if we were to tap on the thing, it should be fairly steady instead of jumping all over the place like it did the last time.
Yep, no change at all.
Okay, great. So now we know we've got a good one. Now, since this is a good one, though, it's not the type of problem that you're having. So if you test your mass airflow sensor and find it to pass the test, you're going to have to go into your diagnostic troubleshooting chart and follow the directions here to arrive at either a bad wiring harness or an electrical connection, maybe even a bad computer.
Okay, but we can do these same tests right on the vehicles. We've got one sitting over there. We'll disconnect our equipment. We'll meet you right over at the car. Okay, now we're over at the vehicle, and Jim, why don't we explain to them how we've hooked the meter and our tester up?
Well, this particular mass airflow sensor is a 3-terminal sensor, so we're going to have to use our universal lead again. It's even marked. We don't have to look this one up in the book. It says A, B, and C, plus, minus, and A, it will be frequency. Now, all we have to do is connect the red lead of our tester to C, because it says plus, that's power.
Sure.
We connect the black lead of the tester to B, because it's got the negative mark there, that's ground. And on the A terminal, where the pulses will come out of, we'll connect our tachometer lead, the red one. And now the other end of the tachometer, the black one, we must ground somewhere. So you could use an engine ground. I like to use the back terminal on the universal tester, because that is the negative terminal when it's connected to a battery. And by the way, the battery we have it connected to is the car's battery. We're using the 12-volt adapter here because this is a 12-volt device.
Sure.
Now, the green lead will be connected to the tach lead because we want to measure those pulses, and it also powers the whole tester up. See, our light just came on when I made that connection.
Sure.
Now, let me just mention this white lead. This is a positive or a hot lead, and I've got it clipped out of the way here so it doesn't bounce on the engine somewhere and perhaps arc and cause a problem. So just get that one clipped out of the way.
Good idea. Then we'll take our tachometer and we'll put that on the 4-cylinder scale. And as you can see, we're not getting any reading with the vehicle. The engine not running, no air going through it. And our light, if you can hold that over here a little bit, Jim, our light is just steady right now. So
that's right. That's very common on really late model mass airflow sensors because they don't produce any reading at all until air is actually blowing across it. So if I go start the engine now, we should be able to get that type of a reading.
Okay, let's try it. Okay, actually getting much of a reading here, so I'm just going to flip her down to another scale. And sure. Okay, I just took it down to the 8-cylinder scale. So if you don't get a reading on your vehicle when it's on the 4-cylinder scale, just flip it down to another scale until you do get your reading.
Right, that'll be common with late model vehicles also. So just use your tachometer, get it onto a scale that gives you some sort of an indication. Now, I'll rev up the engine a little bit, and we'll see if we get any kind of a response. Now you can see that we do have a response, and we know that the sensor is producing a frequency. Now, to test it, to find out if we have any loose connections inside, in the electronics portion, we'll use the screwdriver again to tap test.
Okay. And our reading stays pretty constant.
I'll go turn it off.
Now, the other thing that you want to look for when you're performing a tap test is when you have the engine running, you tap that mass airflow sensor and you listen for any RPM change in the engine. If you've got a sudden drop in RPM or a little blip in RPMs, that's telling you you've got a bad mass airflow.
Let's review how to test a mass airflow sensor that has been removed from the vehicle. Connect the mass airflow sensor tester to a 12-volt power supply. Connect the universal tester leads and the digital volt-ohm-meter leads to the sensor. Turn the meter on and set the scale to 4-cylinder tach or RPM. Observe and record the meter readings. Blow through the sensor and observe the difference in the meter reading. Next, tap on the sensor and observe any meter reading changes. If the mass airflow sensor passes these tests, locate and follow a diagnostic chart to pinpoint your specific problem. Now let's review the testing of a mass airflow sensor while it is still installed on the vehicle. Connect the digital volt-ohm-meter leads and the universal tester leads to the mass airflow sensor. Connect the universal tester power lead to a 12-volt power source. Observe and record the initial meter reading. Start the engine. Observe and compare the meter reading to the initial reading. Increase the engine RPM and watch for a change in the meter reading. Next, tap on the sensor and observe any meter changes or fluctuations in engine RPM.